Today we're looking at section 3-4, and we're talking about zeros of polynomials. This particular video, we're going to talk about the fundamental theorem of algebra. So in a complex number system, every nth degree polynomial function has exactly n zeros. In other words, if I'm talking about a polynomial that has x to the fourth in it, that's my leading number. That means I have 4 zeros, 4 complex zeros. This is a result derived by Carl Gauss. And basically, again, just remember, it may not be 4 real zeros, but there's 4 complex zeros. So it might be an imaginary number in that. You can factor everything in a polynomial down to linear components. So basically it's just saying you can make everything a factor. These are each linear components in a polynomial. Now, these, again, may be complex numbers. They may have imaginary numbers in them, but it's still a linear factor. So let's look at this first one. We have the polynomial of x minus 2. This one is to the first power, so it has exactly 1 zero, and that particular zero happens to be at x equals 2. The second one, here we have a polynomial, it's a quadratic, and if you factor it down, you will get x minus 3, but you get it twice. So this is a second degree. It has 2 zeros, but it's multiplied. It has a multiplicity, a repeated number of 3. So that's still considered 2 zeros. The third degree polynomial here, notice it's to the third. That means I should have 3 zeros of some sort. So if you factor it down, you get this. However, this time, when you go to factor that at x squared plus 4, it ends up being minus 2i and plus 2i. They are imaginary numbers, but they're still considered zeros. So I have 3 zeros at 0. This is considered if I set them each equal to 0, x equals 0, and then set each of these equal to 0, I have x equals 2i and x equals negative 2i.